All right, today we're going to talk about the law of sines. And what's great about the law of sines is that it works for any triangle, not just a right triangle. So notice it's given here, and this is the law of sines. But I'm just going to quickly derive where that came from. So if ABC is any triangle, and we know from yesterday, this would be side B, this would be side A, and side little c. So if I look at this left-hand triangle, I'm going to mark that triangle number 1. I could say that the sine of A was h over c because opposite over hypotenuse. And if I looked at the right-hand triangle, triangle number 2 there, I could say that the sine of c was h over a. And I could very quickly solve for h for both of them. That's a pretty easy get. And if both of those things are equal to h, which is, of course, that one height, then I can set those two things equal. So what I would have c sine A is A sine C. And because I have an equality, and because I kind of know where we're headed, I can do anything to both sides. So I'm going to elect to divide both sides by AC. And lo and behold, what do I get? I get the sine of A over A, because the C's cancel, is equal to the sine of C over C, because the A's cancel. And I could repeat that process to drop the other height and use a different base and get all three being equal. But I'm not going to waste the time to do that. But that's where it comes from. It's a matter of those ratios are the same. And I also want you to know that you can flip it around. So I tend to personally, I'm a flipper. If I'm looking for a side, I put the sides on top. I would use this one. If I'm looking for an angle, then I put the angles on top. It just makes the algebra easier. So you can decide on that. But in my notes, that's how I'm going to do it because, again, I think it's easiest. Now, when you actually use the law of sines, you're not going to use all three of those fractions. You're going to use 2 of the 3. So let's look at an example and we will check it out. First of all, it's nice to know when you can use the law of sines. I'm actually going to draw number 1 and explain this box. If we draw triangle ABC, and as you know, all my drawings, they're not to scale. They're not, mine all look equilateral, even though they're not. If I label the given, so this is 35, angle B, this is angle C, and side B is 9. So that's my given information. Now, looking at what it's asking me, it says find all missing parts of the given triangle. So what's missing? Well, angle A is missing, side A is missing, and side C is missing. So I have to find all 3 of those things. And hopefully you look at one and go, yeah, well, angle A is real easy to find. And of course it is. That's what I would go for first. Because with angle A, I would do, and I don't even think I have to write this down, but I will, 180 minus 35 minus 50, and that gives me angle A to be 95 degrees. I won't even touch my calculator for that one. Now, let's go for A or C. Now, the good news is I'm going to go ahead and write 95 right here. Now, really and truly, I could go for either of those first. I mean, I have side A right here, so I'll just go with that. I could find sine C before I found A. It just doesn't matter. But here's the deal. In order to use the law of sines, notice this statement, a side angle pair is known. What I mean by that, do you see how in this triangle you have a angle B and side B, you know? That's what it means, a side angle pair is known. And then one other side or angle is known. And like I said, I'm going to go for side A first. Well, certainly I have to be able, I mean, when I said you're only going to be using 2 of the 3 fractions, I certainly couldn't use A and C right now because I would have 2 unknowns. So I'm going to use B and A because I'm looking for A and I know B. Now, just what I said before, I like to put my sides on top when I'm looking for a side. So I'm going to do the proportion side A over the sine of A, angle A, is going to be equal to side B over the sine of angle B. And again, the reason I like that so much is because the algebra is so easy. If I wanted to solve for and get A alone, I don't even have to write it down. I can visualize popping that sine of 95 to the other side. So if I get on my calculator, making sure that my mode is in degree mode. So when I go to my calculator, I'm going to put mine in fraction mode so it looks just like my paper. 9 sine of 95, because that would be on top, over sine of 35. And when I type that in, it gives me, and it's 3 decimal places, 15.631. And that's what I have here. And I'll go ahead and put it on my triangle as well. Now, how do I get the third side? Can I do a squared plus b squared equals c squared? No, because this is not a right triangle. So I have to do the law of sines again. Now, which one do I use? Do I use A and C or B and C? Well, theoretically, you could use both, but here's the deal. With side A, this is a rounded value, right? I mean, I cut it off. Plus the fact if I miss A and I use it to find C, I'm going to miss that as well. So I tend to use my given information instead of what I got in the problem. So once again, I'm going to use 9 over sine 35. I'm going to use B because that was the pair that was given to me, is equal to side C over the sine of 50. So I have it on the other, it on the other side, but same thing. All I need to do is write that on my paper. I can visualize popping that over, and let me just type that in again. I could even do a quick thing by hitting second enter. And really, I just need to change this number to 50, do I not? Because I would have 9 sine of 50 over the sine of 35. And I'm going to hit enter. And I would get 12.02. And I go ahead and put the 0. So I get in the habit of rounding to 3 decimal places. And that is my third side. So the last thing I like to do, and the reason why I like to put them all on one triangle, is because I like to make sure that the largest side is across from the largest angle. The longest side is across from the largest angle. The shortest side, which is this one, is across from the smallest angle. Everything seems to look good, so I feel pretty solid on that. All right, let's do number 2. Let's draw the given, and I'm purposely going to put A, B, and C in different places because you know that it doesn't always have to be. That's a weird looking triangle. It doesn't have to be always in the same spot, so I'm going to label my given. This is 10, C is 7, and angle C is 30. Once again, do you notice that I have a paired side, and then I have one other thing. So in this one, there's something I have to go for first. And I hope you see that. That would be angle A. So in order to get, I've got to find angle A, I've got to find angle B, and I've got to find side B. Those are my 3 things I need. I have to go through for angle A first. Why? Because if I do B, I have a lot of unknowns. Now notice I'm going to use sine of A over 10. Notice I'm putting my angles on top this time because it makes the algebra easier. I would have sine of A over 10 equals sine of 30 over 7. Now I am going to write this one out since it's the first time. The sine of A would be 10 sine 30 over 7. Now, if I want to get A alone, I don't divide by the word sine. I take the inverse sine. So I do want you to write this on your paper so you have it if you need to look back at it. When you are looking for an angle, you are going to be using the inverse sine keys. So on my calculator, I'm going to hit second sine. I then get it to be the fraction, and then I type in 10 sine 30, close that parentheses, all over 7, and I am in degree mode, and the calculator pops out for me. And we said to round to the nearest whole, so I'm going to round to 46 degrees, and that's what I got for angle A. Now, once I have angle A, once again, angle B is not going to be a problem. Angle B, of course, I'll shoot it right over here, 180 minus 46 minus 30, and you can type that in or do it in your head, one of the two, and you get 104 degrees. So now I have all the angles. And then finally, I have to go for side B. And for side B, once again, I'm going to use the law of sines, but notice I'm going to put the sides on top to make it easy on myself. B over the sine of 104 is equal to, kind of the same thought, is I always go with my given, okay? Because again, we rounded the 46. So I always go with my given pair. So that would be 7 over sine 30. I hope that you can solve that in your head. Again, I'm going to pop that sine of 104 over. I'm not going to write that on my paper. I'm just going to go to my calculator and type it in. If you need to write it down, that's fine. 7 sine of 104 over sine of 30. Notice I am not hitting the inverse button. You're only hitting the inverse button when you are finding an angle. I am looking for a side, and I get 13.584. 13.584. I do a little check-in to see if my numbers make sense. Shortest side, smallest angle, longest side, largest angle. It's looking pretty good. And that, my friends, is the law of sines. So have fun.